friends, this is Dr. V. Sivanagaraju, Associate Professor in EC Department, IARE. Today, we are going to discuss single tone modulation. In previous lectures, we discussed about amplitude modulation. Before amplitude modulation, what is modulation and types of modulation? We discussed it. Now, single tone modulation. So, what is the single tone modulation? Single tone modulation is a modulation in which the modulation is carried out by a single frequency signal. That means we are using only one signal. If we use more than one, we can call it as multi-tone modulation. Okay, so in single tone modulation, having only one frequency component, and this signal is modulated with a carrier signal. Already we discussed it. For a modulation process, we require two signals. One is message signal or modulating signal, and another one is the carrier signal. Generally, carrier is taken as high frequency and high amplitude signal than the message signal. Okay, so now considering a single frequency modulating signal is nothing but m of t, which is equal to am cos 2 pi fm t. Am is the amplitude of the modulating signal or message signal, and fm is the frequency of the message signal. Okay, and carrier is c of t, which is equal to ac cos 2 pi fct, and s of t what the result of the modulation process we called as modulated signal. Here we are using amplitude modulated, so s of t is the amplitude modulated signal, which is equal to ac of 1 plus ka m of t cos 2 pi fct, where ac is the amplitude of the carrier and ka is the sensitivity, m of t is the message signal, and cos 2 pi fct. Fc is the carrier frequency. Now we are going to substitute m of t in above equation. That m of t is nothing but am cos 2 pi fm t. So substituting m of t in s of t, which is equal to ac of 1 plus ka m of t into cos 2 pi fct. So after substitution, and we are going to simplify the equation, you get s of t is equal to ac of 1 plus mu cos 2 pi fm t into cos of 2 pi fct. Here mu is nothing but modulation index or modulation depth, which is equal to ka into am, amplitude sensitivity and amplitude of message signal. Okay, so s of t, which is equal to, here written as in the previous, ac of 1 plus mu cos 2 pi fm of t cos 2 pi fct. So I am going to multiply cos 2 pi fct into the inner side of the brackets. Then we get this equation. S of t is equal to ac cos 2 pi fct plus ac mu cos 2 pi fct into cos 2 pi fmt. In the second part of that above equation, is it in the form of cos a cos b. So you know that the trigonometric formula cos a cos b, which is equal to 1 by 2 of cos of a minus b plus cos of a plus b. So I am expanding the above equation by using this trigonometric function cos a cos b. So s of t, which is equal to ac cos 2 pi fct plus mu ac by 2 cos 2 pi of fc minus fm of t plus mu ac by 2 cos 2 pi fc plus fm of t. So here we can take the right hand side of two terms is coming. One is the function, the frequency fc minus fm, and there is fc plus fm. So here we can say it is two sides, that is upper sideband and lower sideband is coming. Now we are taking a Fourier transform on both sides of this modulated signal, is nothing but amplitude modulated signal. Then we convert this time domain into frequency domain. So S of t is converted to S of f by applying the Fourier transform. It is converted into like that. S of f, which is equal to AC by 2 into delta of f minus fc plus delta of f plus fc. That means the frequency around this carrier frequencies we get. So here again you can see the previous equation. So S of t, which is equal to AC cos 2 pi fct. So here we are applying the Fourier transform for cos 2 pi fct. You get this value, that is delta of f minus fc plus delta of f plus fc, and remaining is what is mu by AC by 4 of delta of f minus fc minus fm plus delta of f plus fc minus fm, and again the second term mu AC by 4 of delta of f minus fc plus fm plus delta of f plus fc plus fm. This is the frequency spectrum of this ambient modulated signal. So here we can say FM is a single frequency modulating signal or single tone frequency, what it may be called. And the right hand side we having around the carrier we having upper sideband and lower sideband frequencies coming. There is FC plus FM and FC minus FM around this carrier frequency. So this is a frequency spectrum of the single tone amplitude modulated signal. So if mu, what is mu? Mu is the modulation index. If mu is 1, that is 100% modulation is used. So the total power in the two side frequencies of the resulting AM wave is only 1/3 of the total power in the modulated wave. So how this sentence is coming in the coming next slides. So now we are taking the power calculations of AM wave. So S of t, which is equal to AC cos 2 pi fct plus AC mu by 2 cos of 2 pi fc plus fm of t. So what you derived from the last equation, again we are writing here. So the total power P of t, which is equal to PC plus P upper sideband plus P lower sideband. So here the power of AM wave is equal to the sum of powers of carrier, upper sideband and lower sideband frequency components. So we know the standard formula for power of cos signal is Vrms, which is equal to Vm by root 2. Similarly, we are using AC RMS, which is equal to AC by root 2. So the power, V square by R, but here using Vrms. So V square RMS by R. So by using these equations, we are getting the average carrier power PC, which is equal to AC by root 2 of whole square divided by R. So finally, the PC is AC square by 2R. That is the average carrier power. Next, we are good for the sideband power. The average sideband power is either upper sideband or lower sideband. That is P USB, which is equal to P LSB, which is equal to mu AC by 2 root 2 whole square by R. So finally, we get the upper sideband power, which is equal to P of USB is equal to AC square mu square by HR. Similarly, having the same power from the lower sideband also. So PLSB, which is also equal to AC square mu square by HR. So now we are going to getting that total power, which is equal to carrier power plus the two sideband powers. One is upper sideband power and another is lower sideband power. So I am substituting all those values in the total power equation. So PT is equal to AC square by 2R plus AC square mu square by HR for upper sideband and AC square mu square by HR for lower sideband. I am adding these two three components. Okay, so finally the power PT, transmit power, which is equal to PC of 1 plus mu square by 2. Thus we get. So when it is 100% modulation, the mu is equal to 1. So you can substitute in this total power, transmit power, which is equal to PC of 1 plus 1 by 2. That is mu square. You can see in the last equation, PC into 1 plus mu square by 2. For 100% modulation, mu value is 1. Then 1 square is 1. So 1 plus 1 by 2. You get totally 3 by 2. And finally, that carrier power, which is equal to 1 by 1.5 PT. So it's nothing but 0.66 PT. So in AM wave, 66% of the transmit power is used by the carrier and remaining 33% of the power is used by the sidebands, upper sideband and lower sideband. So by using this equation, we can say that that AM ambient modulation is one drawback, that is a wastage of transmit power only by carrier. Okay. So in the next, we are going to suppress the carrier. In the coming lectures, we are going to discuss about how to suppress that carrier, and we are going to using that power. Now, modulation index. How this modulation index is calculated. So modulation index is calculated from the ambient modulated wave. So mu is equal to AM by AC. AM by AC. AM is the amplitude of the message signal. AC is the amplitude of the carrier signal. It is a ratio of amplitude of modulating signal to the amplitude of the carrier signal. So here we can see. So this is our amplitude modulated signal. So in this picture, you can see AC. That is the amplitude of the carrier signal, and AM, amplitude of the message signal. So maximum signal is taken from 0.2. So by using this, we can calculate this mu. So A max is equal to AC plus AM. You can see here A max, which is taken from AC. So the left hand side showing AC, and above that AC you having AM. So that is A max, which is equal to AC plus AM, and A minimum you can see AC minus AM. So that is A minimum. So you can add those two equations, you get your 2AC, which is equal to A max plus A minimum. Therefore, AC is equal to A max plus A minimum by 2. That is AC. Similarly, you can take a equation, subtract equation 2 from equation 1, you get your 2 AM. That is A max minus A minimum. Therefore, AM is equal to A max minus A minimum by 2. So finally, you're going to substitute in the modulation index formula, that is mu equal to AM by AC. Then finally, you get mu is equal to AM minus A max minus A minimum divided by A max plus A minimum. that is mu. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.